Hi, my name is Priya Shanmugam. My metric number is 183685. I would like to present my final year project on Struvite Growth in Gel, supervised by Associate Professor Dr. Muhammad Amran bin Muhammad Saleh, and my coordinator is Associate Professor Dr. Dinia Idati binti Muhammad Ghazi. So in this video, I will present about introduction, problem statement, objective methodology briefly, and also about results and discussion, conclusion, and recommendation. So what is struvite? Struvite is a phosphate mineral which is also known as ammonium magnesium phosphate. Example. For the problem statement, struvite can be used as an alternative for the nitrogen fertilizer. As we all know, nitrogen fertilizer release nitrogen and this will escalate the greenhouse gases in the environment which will cause global warming, and it can also be used as an alternative source for the rock phosphate which is very expensive. So for the first objective is to produce biodegradable superabsorbent polymer to be used as gel media in order to grow struvite. So in this project, I've chosen superabsorbent polymer as my gel media because it has high swelling capacity. So before the researches that has been done previously, I've been used a lot of gel medias like uh, SMS, sodium metasilicate, sodium alginate, but this is the first time of using superabsorbent polymer. And the superabsorbent polymer is a biodegradable SAP. Unlike the one used in commercially, which is being used in sanitary pads and diapers. And the second objective is to investigate the effect of the type of inorganic mineral clay on the swelling kinetics of superabsorbent polymer. In previous researches, the common inorganic mineral clay that has been used is etapalgite. In this research, I've chosen two mineral clays. They are bentonite and kaolin because they are very easily available and also cheap. And the third objective is to form and grow struvite in gel media which can later be used. For the methodology, there are 5 processes has been carried out throughout the experiment. The first step is synthesis of superabsorbent polymer using graph copolymerization. Secondly, characterization of the SAP using SEM and FTIR. Then third one is measurement of the swelling kinetics of the two types of SAP that has been produced in this project. The first step is struvite formation. The fifth one is characteristic of struvite contain SAP using SEM and EDX. For the synthesis of guar gum based superabsorbent polymer, radical graph copolymerization technique was used. Styrene has been used as a hydrophobic monomer. Introduction of hydrophobic monomer into a hydrophilic system will enhance the absorption property, and it also causes changes to the physical property to increase the water absorption. For the biodegradable segment, guar gum was chosen because it's easily available, low cost and non-toxic polysaccharide, and it also a good thickening agent for the formation of MBA is used as the cross-linking agent to avoid the dissolution of hydrophilic polymer chain in aqueous environment, and acrylic acid is used to increase the hydrophilicity of SAP. When the hydrophilicity is increased, the affinity for water will become strong, and the inorganic clay will decrease the entanglement of the polymer chain, and it combines with the styrene to decrease the physical cross-linking, which will provide more space for the water to be absorbed, and this will increase the swelling capacity. For the reaction mechanism, ammonium persulfate. When ammonium persulfate is heated, the persulfate is decomposed into sulfate and ion radicals. The sulfate and ion radical extract hydrogen from the hydroxyl group of guar gum bone. This will result in persulfate saccharide redox system, which causes the active center to initiate free radical polymerization of acrylic acid to form graph polymer. There are two types of SAPs are produced in this project. They are guar gum graph polysodium acrylate styrene kaolin, and guar gum graph polysodium acrylate co-styrene bentonite. So this is the image of the superabsorbent polymers after the polymerization process and before, and this is the image after drying for 72 hours in oven at 70 degrees Celsius. So the texture will become hard and the color will become darker. For the measurement of the swelling, both superabsorbent polymer reach equilibrium at 24th hour. Equilibrium water absorbency of kaolin-based superabsorbent is lower than the bentonite-based superabsorbent because of the layered structure. So the inorganic linear for kaolin you need a tetrahedral sheet and a octahedral sheet. For bentonite, octahedral sheet is sandwiched between two tetrahedral sheets. So kaolin is bonded together by weak hydrogen bond. When water is absorbed into the kaolin particles will split apart. This will decrease the water absorbing capacity. And the hydroxyl group on the surface of the kaolin is replaced with carboxyl group of the grafted polyacrylic acid and esterification occurs. This interaction has no effect on basal. Unlike the kaolin, the structure increases the surface area of bentonite for water absorption. Hydrogen bond formed between amide and acid group and water molecules around the exchangeable cation. This phenomena will increase the basal spacing and exfoliation of this. Exfoliation will increase specific area and it will increase the water absorbability. So this is the image before and after immersing into distilled water, and the weight of the swollen superabsorbent polymer reduces after some time. This is because at the equilibrium, the concentration of water molecule in the SAP is higher than the aqueous surrounding. So the water molecule from SAP will move down the concentration gradient into the surrounding. There are some part of the superabsorbent polymer were detached from SAP and move freely in the water because of lower collision of cross-linker molecules to the propagating chain. So the mass of SAP is reduced. So in this image you can see that the kaolin based SAP has more detached particles compared to the bentonite based SAP. So bentonite SAP is firmer than the kaolin based SAP. For the effect of concentration of solution property, when the concentration of the solution increases, the swelling of the SAP decreases. This is because of the ions present. The ions causes the osmotic pressure difference between the gel and the solution to decrease. For the morphological analysis of superabsorbent polymer, these are the images under. So the bentonite based SAP is more porous compared to kaolin based SAP. Therefore, the bentonite based SAP has more water absorption than the kaolin based. For the FTIR analysis, to analyze the grafting of the superabsorbent polymers. So firstly, the kaolin based superabsorbent polymer spectra as shown. Polymer. The absorption peak at under 1722 per cm indicates ester group is formed during graph copolymerization. For the bentonite based superabsorbent, the disappearance of peak that assigned for OH group stretching in Al aluminium OH in bentonite spectrum indicates esterification between the acrylic acid and the free OH group at montmorillonite of bentonite, and there is a band at 1739.81 per cm contributed to the carbon double bond O stretching of the ester group. Okay, for the struvite formation in superabsorbent polymer, magnesium acetate is used. There are a lot of magnesium sources that can be used like magnesium chloride, but magnesium acetate is used because there are less amount of interfering ions in magnesium acetate sources. So the technique used to insert the or introduce the magnesium acetate into the SAP is single diffusion technique. Before using the single diffusion technique, I've used injection method, but it was not effective as the single diffusion technique because when injecting into the SAP, which has a hard structure, the needle cannot penetrate into the SAP. Then when it's immersed in distilled water, it will become soft. So when we directly inject magnesium acetate into the gel, the magnesium acetate will flow out because of the loose structure of the polymer network. The pH of SAP is maintained at 7.5. This is because at the pH range of 4 to 7, the carboxylic group become ionized and the electrostatic repulsive force between the charge side increase the swelling in SAP. At the same time, at a higher pH value, the swelling is limited by the screening effect of counter ion. So to make sure the SAP has a effective swelling property and able to form struvite, it was maintained at 7.5 pH. Since the guar gum based superabsorbent is not transparent and brown in color, it was difficult to observe the struvite that growing inside the gel as shown in this figure. For the characterization of struvite contained SAP using SEM, the struvite crystals are too tiny to be harvested. So for the analysis using SEM and EDX, we have used the struvite contained SAP in order to determine the structure of the struvite and also the compositional analysis of the struvite in the SAP. Under SEM, it has been observed that both the SAPs with kaolin and bentonite as a mixture of rectangular platelet and prism crystals. So for the characterization of struvite contained SAP using ADX, the table is shown in this slide. The bentonite based SAP consists of 0.47% of calcium which comes from the bentonite, and there's no nitrogen atom in both the ionic radius of dihydrogen phosphate is 223 pm, which is the largest among the ions. When dihydrogen phosphate ion can diffuse into the SAP, it is possible for the other ions to diffuse also. Therefore, there's no problem on the porosity of the superabsorbent polymer to absorb the ions on the presence of no nitrogen in the SAP. So for the reasons can be the very low amount of nitrogen, depletion of ammonium ion when struvite is formed, or the EDX it's difficult for the EDX to detect the nitrogen because of their lower photo. So another reason can be the crystals formed in the SAP could be new boride instead of struvite because new boride consists of magnesium and phosphorus only, and it also has rhombohedral structure, and the suitable pH is 6.99, which is almost similar to the pH of the SAP which is produced in this. So the conclusion, the synthesized superabsorbent polymer is biodegradable, environmental friendly and cost efficient because it's made up of natural resources and inorganic clay mineral, and the swelling capacity of the bentonite based superabsorbent polymer is higher than the superabsorbent. The higher the concentration of the solution of the SAP immersed in, the lower the swelling capacity. The struvite crystals have structure of rectangular platelet. For the recommendation, addition of corrosion and forming technique can increase the water absorbency of SAP. Time allocated for the growth of struvite should be at least more than 1 month. pH of the gel should be further increased to the range more than 9 to grow the struvite into larger size. And the nitrogen detector can be used instead of EDX because it has lowest detect limit, that is 0.003 milligram of nitrogen. Thank you for the attention given.